Maintenant, nous allons en Suisse avec une perspective européenne. On va regarder ce qui se passe ailleurs et de manière plus technique aussi avec les développements de l'Eurocode 5 et bien entendu des études de cas suisses qui seront présentées par Andrea Frangi, directeur de l'Institute of Structural Engineering de l'ETH Zurich.
Thank you very much for the introduction, ladies and gentlemen. It's a great pleasure to be here and to give you a short overview about what I call the state of the art about fire protection and timber structure. But I would like to start with the same slide as Andrew showed previously and Jose, because this slide is always my first slide. I update this slide every year, so next week I can update again. And if you look at the number, we already reached the 1.5 scenario. I'm sorry to tell you, but this is the truth. And you have already seen previously that worldwide, building use and building construction account for 40% of the emission. So we have to work in this sector. And you have seen by Andrew again, we can do something good if we start replacing concrete and steel with timber. But we have to upscale timber construction. This is a very nice study done by, you see, built by nature. We can have a huge impact, but we have to do more with timber. I will not address this point. Then, of course, if we want to build with more timber, there is the issue with the fire. I agree, timber is a combustible material. We built cities for centuries with timber. They have been destroyed. I'm very sorry to say Los Angeles has nothing to do. You are completely wrong. If you rebuild Los Angeles with concrete and there is the fire, wildfire, you will destroy all buildings again. But I don't want to discuss about this point. It's just to clarify few things. Of course, we have seen also fire in the real time. We still have some fire, but we have a lot of new knowledge to take care about this. And as you are doing, and congratulations, what you are doing in France is the right way to go through all these critical points. We have many critical points, and Andrew, you say what you show me is the right way to address the point and to propose solution. We have been doing this for the last 30 years, started by Mario Fontana, 92. You see me on the left side 30 years ago with some more years as a PhD student by Mario. And what we have done in the last 30 years, of course, doing fire-resistant test, normal fire-resistant test, compartment fire-resistant test. We have to understand, I hope, your dear French colleague, you can go back also to this work. I don't want to say you are repeating what you have done. It is important. Everyone needs to get this knowledge. And it's not only fire resistant, it's separating function, it's detailing. Detailing should work. Fire is like water. Always find a way to spread out if you are doing the wrong detailing. We have been working with all material, not only timber, also concrete. Now we have clay. It's very interesting to see how we combine timber with all material. We have to recognize we need hybrid buildings, and probably it's the right way to go. But we know now, fire resistance is not the problem. It was mentioned, make the cross-section big, and you have a good fire resistance. About cavities, detailing, gaps, and so on, you should take care. You should do this detailing in the right way. Otherwise, you have a problem. We are now protecting timber with gypsum plasterboard. We can discuss if this is a good or bad idea. Sometimes you want to protect with gypsum plasterboard. You have to consider what's happened when the gypsum plasterboard fall off. We have an increased charring rate. We need a new charring model to consider this situation, and we have this knowledge. CLT is the most tested product worldwide. Please don't burn any more CLT. We have thousands and thousands and thousands of fire tests. We know how CLT behave in case of fire, and this was important. It's still a young new product. And we discovered many years ago there is falling off of char layer, not only of fire protection. And this causes maybe a second flashover. This causes problem. We have to consider this problem. Can you start a movie? If just because every time that you lose the char layer, the timber furnaces ignite immediately. It's not protected anymore from the char layer, and it burns faster. We have a double charring rate. You see in this video, and of course, if there is no falling off of char layer, CLT behaves like a solid timber panel, so no problem. But we should also recognize the problem, and then we should, of course, propose a solution. Solution is very simple. We use the same model as we are using for the protection system. When the protection system fall off, we have increased charring rate. If we are losing the char layer, we have a double charring rate. So we have proposed the STEM model. And the STEM model recognizes the problem, and in this way, the engineers, they can consider. And I would say in the design, there is no timber structure without connection. And we have to be sure that the connection works also in case of fire. And I have to say here, thanks very much, especially to friends, to CSTB, to Dionys Dima. They have done so many tests in the last 30 years that we have really now a much better knowledge about the fire behavior of connection, which is important. And we know that if we expose steel, it's not good. Slotting steel plates probably is the right way to go, and to protect the steel with timber. There are other problems, but we cannot address all problems in this short presentation. And then timber, and you see here what you are doing is amazing. We are going larger, we are going higher, and then we should recognize a single family house is not like a tall timber building. Maybe a tall timber building should design in a different way, should design for burnout. We should consider that we are doing something different than what we have done in the past. And also in this area, I have to say, we have done 20 years ago, this compartment fire test, already showing that when you have a module completely by wood, you have another fire dynamics if in comparison to the module which is completely protected by gypsum plasterboard. We have to consider also this aspect. And in the last 10 years, I would say 15 years, so many compartment fire tests, United States, Canada, France, UK, so very, very good. We are getting much more understanding and knowledge. And now we have to translate, however, in standardization so that engineers, they can calculate. At ETH, I see there the author, Jochen Smith, with his PhD. We have now a model which allows us to consider wood as additional fuel load, is an additional fuel load, but there are other models developed now that we can start in using also to design timber exposed to a natural fire and not only to the standard fire. The new fire simulator is small but very powerful. In our new fire simulator, we can simulate any kind of fire and environmental, meaning not only the temperature, also the oxygen. You see in the graph, we can adjust the temperature in the furnace, growing phase, fully developed phase, cooling phase. At the same time, we can adjust the oxygen content, considering that in the cooling phase, we introduce oxygen, and then we see how the timber start maybe combusting, charring, smoldering more, and so on. All this knowledge have been translated in guideline, but it's also translated into new Eurocode 95-1-2. You will vote now in April. All country, there is the formal vote of all Eurocode 5 timber part, including the 1.2. This was developed in the last 10 years, and I'm proud that I think it was a long process. It was a long democratic process. We went through 6 inquiries. When I'm chairing this group, you can believe when I get 856 comments, it's not that I'm so happy because we thought, come on, we have provided you the best code. No, we restart, we go through the code. It's important that what we have now in Eurocode 5, it is recognized as state of the art. And it's not the state of the art of Andrea Frangi. It's a long democratic process. You have much more pages to read, but we have 25 years more knowledge to standardize. So I'm sorry, yes, you get much more to read, but we cover much more. And we give you also different level of design in timber structure. You go for simple table, you can do simple calculation, you can go for advanced model. So depending on the case that you are working on, you will choose the right design philosophy. The European charring model was extended, revised, so that you can now design with this simple model all timber structural elements. We have now distinguished elements who fulfill the bond line integrity, no falling off of char layer. You have this set of charring model, calculation model, and then you have, however, also the model for products which do not fulfill the bond line integrity. So we have really now different model for different situations. And then, of course, gypsum plasterboard, any kind of fire protection system. Now you have for the first time generic equation. Of course, this company will give you always a better value because they have done testing, they have certification. But in a preliminary phase, now you have generic equation. You can calculate falling off. You can calculate the failure time of the fire protection system, which is, I think, again, a very good improvement. And if you don't want to calculate, pick up the table. We have prepared some table where you just have to read the value. And for CLT, which is, I would say, a little complicated, again, some table. You don't have to calculate, just read the table, and you get what you are looking for. I have already mentioned effective cross-section was revised, extended to all kinds of structural elements. It's a simple model, and we have revised also the zero strength layer. It's not anymore 7 millimeter. Forget the 7 millimeter. It was wrong. We have to recognize we have other value, but I think it's the state of the art that we have now in timber engineering and fire. Connection, I have to say, really now we extended the rules up to 2 hour fire resistance, not only half hour. So we have, or you have, for the common connection now, also good design model, simple model based on table, or some more empirical, analytical model that you are calculating. Advanced model. We want also sometimes to do a numerical simulation, thermal analysis combined with mechanical analysis. Then you need a lot of information and a lot of expertise. We try to give this knowledge. giving the properties that you need for this kind of simulation for all material, insulation, gypsum, timber, clay, and so on, so that you can start, if you want to go a little more in a, let's say, advanced calculation. Detailing, I have already mentioned. We cannot provide the 1,000 pages that you find in Switzerland, now in UK with all detailing, but we give at least few pages with the most important principle. You have to fulfill this if you want to use the previous equation. So it is very important that detailing is connecting with the calculation model. We introduced the Annex B, normative. I repeat, normative. You cannot do what you want because it's normative. And this allows with a simple test to say bond line integrity, yes or no. And we have also a very severe criteria. So if you pass this test, you can say bond line integrity is fine. And of course now, this is only an annex, but it is a very important annex. You will listen much more this afternoon by Daniel Brandon, is coming here. Now I see Joachim, there is Luc Bisbee, and so on. We have now first instrument to go beyond the ISO standard fire exposure. We introduce in the Eurocode 1 the basis for this calculation, how you can consider timber as additional fuel. And in the Eurocode 5, you have even 2 models showing how you can approach this problem. So feel free to start using the second generation of Eurocode 5. It will be available this year, and then, of course, all countries need some time preparing national annex, additional document. But I think the second generation of all Eurocode, not only timber, I think is really a huge improvement in the standardization. And I will not leave the third generation. It takes 20 years for each generation. So imagine the time that we are spending in this standardization. I'm proud that we calculate in the same way. But with regard to requirement, each country is doing in a different way. This is the reality. So the next step is try to have more harmonization in the requirement that we set. And I would say, luckily, live in Switzerland, which is the most liberal country. We have just the best fire safety regulation worldwide for the timber structure. But this was not for the last 50 years. Until January 1st, 2005 in Switzerland, you could build only a building with 2 stories. But I mentioned we have been working with fire brigades, with authority, with industry for the last 40 years, 30 years. And the authority recognizes we can build fire-safe timber building. And now with the new regulation, we don't have any limit for timber as building material. And what we are doing for the last 20 years in Switzerland, we are just really implementing the knowledge. These multi-story timber buildings in the city of Zurich, Winterthur, Basel, Lausanne is not a single family house in the mountain. These are maybe residential area for Switzerland. 500 apartments is huge. Of course, in France it's nothing. We are a small country. But it's just to show you what we are doing. This is the state of the art. Medium-rise building up to 30 meters, we can do and we shall do. And now, of course, we have the competition for the tall buildings. That's good. Ferrari in the construction, let's say, Formula One, maybe. Ferrari is just one company. But This is important because we want also to go beyond maybe what we can do as a normal basis. Now this is one of tall building in Switzerland, 60-meter high, 15-story. Andrew, in 15 weeks built, so you cannot be faster. And the fire requirement, 60-minute fire resistant with sprinkler, exposed linear timber member. You enter the building, you see the timber. And this is now currently the highest, 75, the red wood, because it's made of glulam, made of pitch. This is the structure that you see when you enter the building. It's so beautiful, really. And you will see the structure. Fire safety, dear ladies and gentlemen, is not primarily a question of building material, but of concept. And with concept, we mean education, quality assurance, careful design and execution, maintenance. This is our concept. Education is important. I'm at ETH. We have now started a new MIS in fire safety engineering. We recognize we have to educate more, especially the engineers who are now in the practice. Maybe the student, they can catch up, but more people who are in the practice. The documentation that you are doing in UK, I think is really the right way. We have something similar in Switzerland, the so-called lignum documentation, covering all aspects and fire resistant in only one very specific aspect. Detailing, again, so important, execution, and so on. And for the French colleague, you have this also in French. So maybe you can copy a few things, I hope so. Quality of construction on paper is always perfect. Somebody should check that you are doing the right things also on the construction side. And in Switzerland, we have the so-called fire safety engineer, a person who takes responsibility that what has been designed is also executed. And he's going into the factory, checking that the timber frame assembly is filled with mineral wool, maybe, if it's needed, and not with maybe wood fiber. So you have to check before maybe the elements are done. And then you check what happened during the construction site. Is done in the right way? Yes, otherwise you ask to fix the problem. Feel free to come to visit us. The small neighbor country is what we can offer you in few years. I just pick up the tall timber building who are under planning. They will be finished in the next year. We go up to 110 meters, and we will go even higher, and we will go with timber because we like cheese in Switzerland. We export cheese, and we are proud about the quality of our cheese. And the Swiss cheese approach is our approach for fire safety. Fire safety is not a question of building material. And it was already repeated many times, also by the previous speaker. You have to consider many measures, starting from detection, no, even prevention is always the cheapest way to solve the problem. There will be no fire. And by adding all these measures, we can build in Switzerland fire-safe timber building. Thank you very much for your attention.